Alright, so welcome to another installment on the Mariner Biology YouTube channel. This one's about negative feedback, and what we're going to try to do to get you to understand the concept of feedback and homeostasis. We're actually going to have you graph out an example of negative feedback using blood sugar or blood glucose. So what you're about to see is an example that shows the process, how we're going to graph a set of data and try to interpret the graph and see if we can analyze it and understand more about feedback as a result. Okay, so what we're doing is we're going to measure the blood glucose levels of somebody over a 12-hour period. Okay, and the units for blood glucose are milligrams per deciliter. And what that means is, well, first of all, a deciliter is a tenth of a liter, and the number that you see is the number of milligrams in that tenth of a liter of blood in this person, and we're measuring that every hour. Okay, so here's the data that we gathered, and you got time on the top and blood glucose levels on the bottom, and we've got a measurement every hour. Okay, so looking at that data, what we have to do is decide what's going to be on the x-axis and what's going to be on the y-axis when we go ahead and graph this data. So, we'll just lay that out for you. On the x-axis, we're going to have time in hours, and on the y-axis, it's still, again, that thing that we're measuring, which in this case is blood glucose in milligrams per deciliter again. Okay, then the next thing we need to do is figure out how to scale our axes. So that, remember, so every box up an axis is the same value, or has the same value. So we can see that time, the maximum is 12 hours, and we're going to have a grid that's 24 squares going across. So how are we going to calculate how much each square is worth? All right, let's go ahead and do that math. It's a division problem, and we're going to take the number of hours and we're going to divide it by the number of squares. And that's going to give us 0.5 hours or a half hour per square. We want to keep it in hours, not minutes. Okay? So that means that every 2 squares would be 1 hour. Alright, and then for the y-axis, right, we've got 120 milligrams per deciliter is our highest value, and we've got 20 squares going up the y-axis. So let's do that math. And we get 6 milligrams per deciliter. Right? 120 divided by 20 is 6. So each box going up the y-axis is going to have a value of 6. Okay, so let's go to our next slide. All right, and so we're transferring that data table over again so that we can actually make our graph. We're going to construct the graph, and so we'll set up those axes and we'll number them to the scale we established. Right, so you can see along the x-axis, every other box is an hour. And notice that I started with 1 at the very beginning, right where the intersection between the x-axis and the y-axis is. Because I want to start my graph from the y-axis. I want it to leave from the y-axis. Okay, so let's throw up our labels on there and our units. Okay, don't forget to do that when you're graphing. And then we'll start plotting our points. Okay, so there's our first point. At 1 hour, we had a blood glucose level of 120 milligrams per deciliter, and then we dropped down to 100 in the second hour, and then we'll just go ahead and plot out the rest of those points. Okay, and then we can connect them. Alright, and then what we want to do is establish our set point. We can see that the graph is up and down, peaks and valleys, but what we want to see is where it's actually trying to get to as it goes too low or it goes too high. Alright, so this line that I've drawn across is the approximate set point based on the data that we've collected. Okay, and that ends up being approximately 80 milligrams per deciliter. So let's go ahead and look at that. Okay, so we can see now that the blood glucose is oscillating around a set point. Whenever you see this, whenever you see a graph going above and below a set point, you can be confident that that's an example of negative feedback. If the glucose level is too low, then what's going to happen is you're going to do the opposite. You're going to counteract that. You're going to negate it. And so that's why we call it negative feedback, because you're negating it or counteracting it to get back to the set point. If it goes too far above, your body's going to respond by doing things to bring it back down to the set point. So it's too high, you got to get a little bit lower. Again, you're counteracting the current condition to get back to that set point where you want to be. Okay, the narrow range of conditions that our body's happiest at. Okay, so we got two parts of the graph that we're going to discuss in the next slide. And then, again, the big question is just make sure that you know why this is negative feedback. And again, you're looking at the graph, seeing it oscillate around a set point, and that's your big clue there. Okay, so we'll go to the next slide now. We'll transfer our graph because now we want to analyze and interpret the graph. What does it mean? And try to see what's going on at different points in the graph. So we're going to look at point A and point B. So the first question about point A, the main one, is how will your body respond at that point on the graph? Okay, and so what we're going to think about is what we've learned in class. When the blood glucose gets too low, how does your body respond? What gland is involved? What hormone does that gland secrete? Where does the hormone go? What's the target cell? What's going to happen in the target cell once the hormone hits that receptor? Okay, so let's think about that. So when glucose is too low, your body responds by having the pancreas secrete glucagon, and that glucagon goes to the liver, and then the liver has those glycogen stores, and it's going to convert them to glucose and release them into the bloodstream, and your blood sugar is going to increase back towards the set point. Again, you're negating the low blood sugar, you're counteracting the low blood sugar. Okay, so that's what's going on in that point in the graph. So what I'm going to do, I'm just going to ask you the question about how your body will respond at point B on the graph. Okay, think about the example right above, and just think about which arrows need to be switched. There's the name of the hormone needs to change, and this time we're going to convert glucose into glycogen instead of breaking down glycogen with a hydrolysis reaction and putting it back to glucose. Okay, so you think about those things. I'm not going to give you the answer to that one. And then what you're going to use is this to do the assignment that I gave you in class. This is your background. This is what you're going to use as an example. I'm going to give you a different condition with different values, but you're going to do the same exact thing. Okay, so good luck on that, and I hope this helped.